Welcome everyone to a new video, this time on the topic of statistical hypothesis testing. I'm only going to briefly talk about the main concepts and the main problems of this topic. I encourage you to also read carefully all the slides. This is going to be just a quick summary about the topics, but it is not only the necessary material that you need to study for the midterm exam and obviously for the final exam of the subject, okay? So having said that, let us go with it. This topic is split in two main parts. First of all, we need to understand the theoretical concepts regarding the null hypothesis and alternative hypothesis, basically, and also the p-value, okay? The null hypothesis is going to be the hypothesis that we are going to falsify according to data in order to accept the complementary hypothesis, that is going to be the alternative hypothesis. And what is the probability that the empirical data supports the null hypothesis? That is simply the p-value, okay? So just these concepts. And in the second part, we are going to see examples of how we do apply the previous concepts in practice. Okay, so 5 different cases, parametric test, and finally 3 non-parametrical tests. So what is a hypothesis? A hypothesis is basically a statement of a random phenomenon. Okay, so basically, are my sales going down? Is the price of this product lower than 30? Is this data normally distributed? Okay, so things that we can see whether data it's compatible with them or not. So two basic types of hypotheses: parametric ones that are regarding a quantity, regarding a parameter. Okay, for example, the monthly consumption in mobile of Blue Steel customers, and no parameter hypothesis regarding generally to model distributions. For example, is the data normally distributed? Okay, are my sales normally distributed? For example, if I am a CEO of a company and I want to see how many sales do my salesman have, so this is a non-parametric hypothesis. We can see it visualized. We can visualize here a parametric hypothesis. Here the vertical lines are different values of the car prices. And we can see also as well whether the blue distribution, this blue distribution is normal or not. In this case, for example, the blue distribution is not normal because it has a lot of right skewness. So, for example, the Wilcox test of normality is going to give us a really high p-value indicated, low p-value, sorry, indicated, well, the car distribution is not normal. Okay, so in science, in order to advance the status quo of scientific discoveries, okay, we always apply this methodology. We basically need to show that the status quo, the current knowledge about a parameter, also called the null hypothesis, is not compatible with the empirical evidence that we can observe. Okay, so basically doing the same thing that I have previously talked to you about in topic 3. We gather empirical data, we show that this empirical data is not compatible with the null hypothesis, then we reject the null hypothesis and accept the alternative hypothesis. Okay, so this is basically based on philosophy by Karl Popper. You can see him right now, a famous philosopher. Then the only way to talk about science is through falsification of hypotheses. Okay, so the null hypothesis can have several types in parametric test. Okay, we can have different signs. We can have an equal, lower than equal, or higher than equal. Here, what you need to know is that the sign equal, it's always present in the null hypothesis, never in the alternative hypothesis. And another important thing that you need to take into account is that null hypothesis and alternative hypothesis, we have the parameters. Here, for example, the mu. Never the statistics, never the sample mean, never the sample median, and so on. Why? Because we are trying to show that the theoretical knowledge that we have, it's compatible or not with data. And this refers always to the parameters. Why? Because the parameter is a fixed amount and unknown generally that we study in theory. So when we do the scientific method, what we try to do is to show that the current scientific theory about anything, for example, about a certain business strategy, whether we can merge with a company or not, whether our portfolio is profitable or not, or whatever, we are trying to say, to show with empirical data that this is not really likely. Okay, so this is what you need to know is that in alternative hypothesis and null hypothesis, we always have parameters. We do not have statistics. The alternative hypothesis is the complementary one to the null hypothesis. So for example, if the null hypothesis is the sales are lower or equal than, I don't know, 50,000 euros, then the alternative hypothesis would be the sales are higher than 50,000 euros. Okay, so this is really important. Another example. The proportion of people that go to an event, to event 1, it's equal to the proportion of people that goes to event 2. Okay, so the alternative hypothesis would be the proportion of people that go to event 1 is different than the proportion of people that go to event 2. And always the parameters, and always the equal sign in the null hypothesis, not in the alternative hypothesis. Okay, the alternative hypothesis is the hypothesis that we accept if the data compatible with the null hypothesis, it's really unlikely for it to be. And what does that measure? How we do measure this quantity? We are going to measure it with the p-value, okay? The p-value or the type 1 error, that it's basically the risk, okay? It's the probability that the empirical data is compatible with the null hypothesis, okay? Basically, the p-value, it's measured in an area, it's an integral of the distribution of the statistics, and this integral, it's basically, hey, this is the probability that the null hypothesis is compatible with the data. Okay, so if this probability is really, really, really low, that means that the empirical evidence is not compatible with the null hypothesis. So if that probability is below a threshold, then we are going to reject the null hypothesis and we are going to accept the alternative hypothesis. This threshold is usually called significance or confidence level, and it takes the value usually in strategy and finance of a 5%. Okay, so if the p-value is below a 5%, we are going to reject the null hypothesis and accept the alternative hypothesis. If for some reason this significance level has another value, for example 1%, if the p-value has a value lower than 1%, then we are going to reject the null hypothesis and accept the alternative hypothesis. This significance level is subjective to the experimenter. Okay, it's a value that the experimenter chooses previously of doing the experiment. Okay, so it's the amount of risk that you are going to assume to be wrong. Okay, so if there is a 4% of chance that the null hypothesis is true and your significance level is 5, you are going to change the status quo. Okay, you might be wrong. In science, we don't have certainties, never. In science, we hate the word true or false. We don't use this word. We cannot know whether something is true or false. We just know whether something is likely or unlikely. And this is basically what we are going to represent through the confidence level and also through the p-value. Okay, if the p-value is higher than the confidence level, then we cannot reject the null hypothesis. We cannot change the status quo. We need to continue working towards this goal. Okay, and this is basically the important thing about the p-value, the null hypothesis, and the alternative hypothesis. So in the next video, I am going to talk about how do we extract the p-value in certain cases. So see you in the next video.